So what's new today is that we're going to be encountering horizontal asymptotes that are slanted. So just as a refresher, yesterday, when you had something like 2x plus something all over x squared plus something, and we wanted to find the horizontal asymptote, what we would be doing is we would look at the lead coefficients, and we would think, what would that be kind of as a parent function? And we know what 1 over x looks like. So we kind of go from that and we say, all right, I know because the parent function has a horizontal asymptote at y equals 0, this guy will also have y equals 0 being the horizontal asymptote. So there were other times when we had something like 3x squared plus dot 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 and then 6x squared plus dot dot dot. So when we're still doing the horizontal asymptote, we're still thinking, what is the end behavior function? Or what are the leads doing? Because the other stuff back here are not going to affect things when we go way out to the side on my graph. So if I do the same thing, in this case I don't get an end behavior function really, what I get is just a number. And that determines the horizontal asymptote. Now today we're going to see things like 6x cubed all over 7x squared, and so we're going to have powers on top being larger. You're still going to do the same sort of thing. What will end up happening is we will get something like 6/7 x. And what that means is, for your graph, you're going to have something that has a slope of 6/7 as your horizontal asymptote. Now, how do you actually find the horizontal asymptote? That is what this lesson is about. So, let's go back to this example. We're going to start off doing the things that we know already. We want to find x-intercepts. So we're going to be factoring this, and that's going to come out to be x minus 3, x minus 1, all over x minus 2. And reality check, is there a hole? No, there is no repeated factor on top and on bottom, so we don't have to worry about holes. But my x-intercepts are when the top is 0, so 3, 0 is an intercept, and 1, 0 is. Then we talked about the y-intercept. The y-intercept is when we plug 0 in, and yesterday we talked about how, actually, that's just going to be the last terms, kind of like when we were graphing polynomials. So that's going to be, in this case, negative 3/2. Already, I can be sketching what this is going to look like. 1, 2, 3, 0, and 1, 0. And I know negative 3/2 is, if I mark it off, is about negative 1.5 right there. Okay. Vertical asymptotes are going to be when the bottom is 0. That's when x is 2. So I'm going to have a vertical asymptote right at 2. Okay, so here's the new part. You'll notice that for the horizontal asymptote, the power is larger on top when we think about the end behavior function. So what we have to do then is actually long divide. Now in this case, you could synthetically divide because what you're dividing by is linear, but I prefer to do this because it's pretty quick. So, whoops, not x squared. X times, that would be x squared minus 2x. And just be careful when you subtract. This will cancel. Negative 4 minus a negative 2 is negative 4 plus 2, which is negative 2x. And drop 3. Alright, and so this is going to be negative 2. And when we subtract, 3 minus 4 is negative 1. So here's the good news. The good news is that this right here is your slant asymptote. And so, your horizontal asymptote is y equals x minus 2. Now, how would we graph this? Well, it's an mx plus b. So we start there, and we go up at a slope of 1. And that's our asymptote. Now, you're still going to have kind of the feeling of the 1 over x going on here. And we know that on the right side, the curve has to be below the asymptote because we already have a point there. So it's going to look kind of like this. And on top, we already have 2 points here, so it's going to look something like this. Okay, so the great thing about this is we can always use decimals to make sure that what we have is correct. So let me resize decimals here. And I have already graphed it out. So let's double check some things. X equals 2 is my vertical asymptote. I have intercept right there, there, and there. And my line, I've already graphed the asymptote. You can see that this never quite touches it, but it approaches it. And so that's the graph of our rational expression. All right, so here's one for you to try now. All right, you should pause the video, find the x-intercepts, y-intercepts, vertical asymptotes, and then try finding the new horizontal asymptote. And remember, these things are always easier if you factor, so make sure you factor the top first. Okay, so what I'm going to do on top is factor out a negative 1. And what would be left over is x squared minus 1 on top. Schofield life tip, if there's a leading negative coefficient, you should always factor that out as a GCF. Almost always it will help. And the point of that is, now I can do a difference of squares, and that is fully factored. All right, let's talk about x-intercepts. X-intercepts will be negative 1, 0, and 1, 0. Y-intercepts, that's going to be when we plug 0 in, or again, just the last numbers, because these will disappear when 0 is plugged in. So this would be 0, negative 1 half. Okay, now vertical asymptotes, the bottom is 0 at 2, so x equals 2. And I'm just going to graph what I have so far. Negative 1, 1, 0, negative 1 half. Okay, the last thing we need to do, I'm sorry, we should have x equals 2 be our vertical asymptote. The next thing we need to do is the horizontal asymptote. So let's long divide. And remember that you don't have an x term, so you need to include it when you're in your division. And yes, you could be synthetically dividing, but again, I just prefer to just long divide these because it's pretty quick. So negative x times x will give me negative x squared. That will turn into 2x. When I subtract, I will get negative 2x plus 1. And then this right here times x should be negative 2 to get negative 2x. Now again, here's the nice thing about this. The remainder actually doesn't matter. Y equals this should be my asymptote. So alright, if this is 1 and this is 2, there's where my asymptote should start. And I'm having a slope of negative 1. Now on a graph, you're going to be able to draw an asymptote a little more accurately. Right now, I'm just trying to represent a slope of negative 1 over 1 down 1, just as best I can without an actual grid. Okay, so you have the left side. You have to graph above or below, but we know it's going to be above because of the points that we have already. On the right side, it's either above or below, but realize if it was above here, we would have found an intercept like right there, because if I drew it above, it would have to pass through. So I know it's actually going to be something like this. And again, let's just check this on decimal. So I have this graphed, and if you imagine a line starting right there, actually I can just graph it out here. Whoops. Here we go. Negative x minus 2 is that asymptote, and it is as we thought. Alright, so there's one last one that's going to be a little more tricky. Okay, so this one's a little more tricky because, well, first of all, there's a GCF on top and on bottom. So I'm going to factor that out first. On bottom, the GCF is 4. Alright, and again, I need to keep factoring. These problems will almost always be factorable, and that just makes things a little faster because you can get your zeros more easily. So again, I don't have any holes. For these problems, we just haven't encountered a factor on top and on bottom. So let's talk about x-intercepts. We're going to have 0, 0, 4, 0, and negative 2, 0. For the y-intercepts, if I plug 0 in, I actually get 0, 0. And if you're paying attention, you would have known that already, because the x-intercept of 0, 0 means it is also a y-intercept. That just happens sometimes. 1, 2, 3, 4, and negative 2. Alright, so x-intercepts and y-intercepts are taken care of. How about the vertical asymptote? Well, we have 2 now. We have x equals 1 and x equals negative 1. Alright. Now the last thing here. For the horizontal asymptote, we're going to again have a slant asymptote because the power is larger on top. And so we will be long dividing. Now here, unless you know some tricks, you really do have to long divide this way because the bottom is not linear. Okay, and this is also the difficult part. People run into this and they think, what? Times 4 would give me 1. Well, you can have fractions. And then x times x squared will give me x cubed. So 1/4 times 1 gives me 1. X times x squared gives me x cubed. So you will encounter fractions sometimes, but also don't be afraid of this because this is an mx plus b, right? So the slopes will sometimes be fractions. Now I'm going to multiply this by negative 4, which will give me negative 1x. Another common mistake, this is an x, so please do not put it under the x squared. That will really mess up your asymptote. So 8 minus a minus 1 is 9x. And we just drop down the negative 2x squared. Okay, so this is nice. What times 4 would give me negative 2? That's negative 1/2. Yep, so that would be negative 2x squared, and this would be positive 2. But the rest is history. We actually have our slant asymptote right now. So down at negative 1/2, we're going up at a slope of 4. So 1, 2, 3, 4, 1. And then 1, 2, 3, 4, 1. And again, I'm just kind of estimating when I'm doing it on paper. When you have a graph, you should be able to make a very accurate slant asymptote. Alright, so we know it's going to look something like this right here because I have a point below. And I have a point above over here, so it's going to look something like this. Now understand me, in the middle you could have a couple things. You can bounce off, you can be passing through, you could be passing through this way, or you could bounce off the other way. Because remember, the horizontal asymptote does not, you can cross it. It's just at the end behaviors where it should be approaching it. So how would I know which way to go? Well, we would do test points. Now, I'm going to not do a test point right now because I don't want to take forever here. So here is the graph. And that matches up with what we have here. We would just do a couple test points to see that, yes, indeed, it goes through like this, kind of like a lane change like that. Okay, and if we want to verify that our mx plus b is working, okay, I'm going to type in y equals 1/4 x minus 1 half. And look at that. That line is the slant asymptote. So just one more thing. Some people would say that this is not a horizontal asymptote because it's not completely horizontal. But I just consider it a slanted horizontal asymptote. It still is kind of going horizontal. So don't let that confuse you if you're reading the book or looking elsewhere.